Okay, guys, what we want to do now is just talk about the different types of forces. FW is weight, which is mass times gravity, gravity being 9.8. Make sure your mass is in kilograms, and G, of course, will be the acceleration due to gravity, negative 9.8. Now, weight always acts straight down. So whenever you want to draw a weight, that force, it is straight down. Another type of force is the normal force, and that is always perpendicular to a surface. And I guess my pen is not going to work very well right now. Perpendicular to a surface. So if you have a book on a table, the normal force is perpendicular to the surface. And of course we would draw FW, or the weight, straight down. So we're going to draw and label some force diagrams. FT is tension. This is a force due to a wire or string. This can act in any direction depending on which direction the string is holding the object. And then F sub F here is friction, and that is always the force that opposes motion. And again, I don't know why my pen is acting very strange here. I swear my handwriting is not this bad. So if you have weight, always straight down, mass times gravity. Normal force is always perpendicular to a surface. Tension is due to a wire or string, so you just draw the arrow the direction the string is pulling or the wire is pulling. And then friction is anything that opposes motion. So if you're moving to the right, friction would act to the left. If you are moving up to the right, friction would act down. Okay, it is always opposite to the motion. Friction is always opposite to the motion. All right, so now we want to label the forces in a given situation. So here we have a ball, or a weight, if you will, an object hanging from a string that is attached to a ceiling. So we want to label the forces. Well, all objects have a weight. And since the object is on a string, we also have a tension force, Ft. And that's it. That's how you would do this very simple force diagram. So let's look at an object on a table. It's motionless. And we want to label these forces. Well, again, you would always have weight. It's straight down. And in this case, you would have a normal force. A normal force. Anytime you are attached to a surface, you have a normal force that is perpendicular. Another very classic example, which we're going to do a lot, is what if you're on an incline? Okay, let's label those forces. Weight is always straight down. Notice how I draw the normal force. It is perpendicular to the surface. Okay. Now, normally this box would want to slide down, right, because of gravitational force. But it doesn't, so that tells me there must be some friction acting up the ramp to stop it from sliding. So right here we just have three very basic, if you will, force diagrams. And you just want to label where appropriate the weight, the normal force, the tension, or friction, depending on the situation. All right, let's look at this quick little example here. So you have an object being pushed to the right with 12 newtons and pulled to the left with 5 newtons. We want to find the net force and the acceleration. Well, our net force, we're going to say 12 newtons positive plus a negative 5 newtons to the left. And that gives us 7 newtons to the right. Now let's say the mass of this object is 3 kilograms. Well, if we look at Newton's second law, we know our net force is 7. We know our mass is 3 kilograms. So now we can solve for A. And 7 divided by 3 is 2.33 meters per second squared. And my pen is not working very well, guys. I don't know what's going on with it, but my handwriting is not this bad. But hopefully you can understand what I'm doing. So this is a type of problem that we want to practice. All right, let's look at this type of problem. We have 5 newtons north, 4 newtons to the right. We want to find the net force, and the acceleration, we'll just say the mass is 2 kilograms of this object. So it's being pushed north 5 newtons and to the right 4 newtons. Well, for this, we just want to imagine this turning into a right triangle, and we want to find that resultant. That would be the net force. Okay, so that will just be using Pythagorean theorem. 5 squared plus 4 squared. All right, oh, we got to remember that's the hypotenuse squared, of course. So 25 plus 16. Oops, that I did write incorrectly. I can't blame that on the pen. 2, 3 equals 41. So the net force is the square root of 41, which I gotta find the square root on this calculator here. So the square root of 41 is 6.4 newtons. And of course, since it is a vector, we should probably find the angle, which is the inverse tangent of 5 over 4. Of course, make sure your calculator is in degrees. And I get 51 degrees. Okay, so for this type of problem, you just want to refer back to our Pythagorean theorem and try to find the hypotenuse and then find the angle. Now, what would our acceleration be? Well, F equals ma. F is 6.4. Our mass was 2 kilograms. So our acceleration, 6.4 divided by 2. And you get 3.2 meters per second squared. Okay, so this is a second type of problem, if you will, that you would be expected to try to figure out. Okay, so here's a little tougher example. Again, we want to find the net force. And actually on this one, we're just going to find the net force because we're going to assume the object is at rest. Well, actually, once we find the net force, and we'll just say the mass is 10 kilograms. I just made this problem up off the top of my head, so I don't even know if it'll work. Then we can find the acceleration. Okay, but this one's a little tougher because we have 2 vectors, and one of them is going to be at an angle. And we want to find the net force. So what you have to do here is you have to find the force in the x direction and the force in the y direction. Okay, so we have our weight. This one straight down only acts in the y direction. So that's going to be, excuse me, 500 newtons plus the y component of the 450 newtons. So what you have to remember there is we need to find the y and the x here, where I drew the dashed lines, for this 450 newton force. Well, if this angle here is 30, and this is where it gets a little confusing, is you got to remember your complementary angles. I know this is 30 degrees, so this on the inside has to be 60 degrees. So again, if this is a 30-degree incline, and I draw the complementary angles, if you've learned that in geometry, I know this is 30, and so this is 60. Okay, so this would be, for the y component, it'd be 450 newtons plus the sine, 450 times the sine of 60. Now the x component will be 450 times the cosine of 60. So 450 times the cosine, okay, my calculator is being goofy. So 450 times the cosine of 60 is 225 newtons. Okay. 60 sine times 450 is 389. So the force in the y direction actually this, I apologize, this should be negative 500. Now that I look at this, right, that's in the y direction. So it's negative 111 newtons. So to find the net force, I would use Pythagoras again, the square root of fx squared plus fy squared. Square root of 225 squared plus negative 111 squared. And that will give me the net force here. So it will be the square root. Golly, this pen is not doing anything right tonight. I apologize, guys. If you have any questions, of course, let me know. So our net force would be 250 newtons. 250 newtons. So we should find the angle, of course. That's the inverse tangent of the y over the x so if you do that, our angle will be 26.2. Now if you leave that as a negative 111, which is fine, it means you have a negative angle, which means you're just going down, into that fourth quadrant, if you will. If we wanted to find the acceleration, we know our net force is 250. So 250 equals 10 kilograms times A. So A is 25.0 meters per second squared. So that's tough. So what you do here is you find the X component, okay? You find the Y component, then you use Pythagoras to find the net force, and then you find the angle by the inverse tangent. The key to this is if your incline is at a 30 degrees, then when you draw your triangle here this way, you want to make sure you use 60 degrees. 60 degrees. Okay? Let me know if you have any questions. That's a tough one. Okay, so for this type of problem, we want to solve for the normal force. We have a 50-degree angle. On our incline, we have a weight of 100 newtons. So what you do here is you draw the weight vector going this way, and we know that's 100 newtons. And if I drew this to scale, it would kind of connect where Fn becomes our hypotenuse. And if that's 50 degrees, we know the angle inside is 50 degrees. Okay, so if I just make a different looking triangle, we have 100 newtons. We have Fn. We have 50 degrees. And we have the other side of our triangle. Okay, so to find Fn, it will be 100, the weight, times, now 100 newtons corresponds to the cosine of 50 degrees. So remember your trigonometry, the normal force, the hypotenuse now, will be 100 newtons, the adjacent side, times the cosine of 50. And the cosine of 50 is 0.643 times 100. So my normal force golly, this pen is not working at all, is 64.3 newtons. So make the triangle and then use the cosine of the angle.